welcome to our channel. In this session, we will discuss these examples of designing DFA. The first one is design a DFA that contains exactly two zeros. Here my input alphabet sigma consists of 0, 1. Assume my sigma input consists of 0, 1. What is the condition they given? Exactly two zeros. Now, what is the language accepted? 0, 0. Suppose 1, 0, 0. 1, 0, 1, 0. Here there is no condition of consecutive. Then the entire string, two zeros are present. That is the thing. For example, 1, 1, 0, 1, 1, 0. Like this. These strings are accepted. Now, we are writing the finite automata like this Q0 with only two zeros. 0, Q1 with 0, now Q2. Okay, this is the base case. If you observe the previous example in the last session, there we are writing two consecutive zeros. That means in between 0, 0, there is no self loop is also allowed. But here if you observe carefully, before 0, you can have any number of ones, not a problem. Suppose see this example 1, 0, 0. This is accepted. And suppose this example 0, 1, 1, 0. This type of string is accepted. 0. Self loop is 1. That is accepted. And this one 0, 1, 1, 0, 1. This is also accepted. You got the point? Before 0 and after 0, any number of ones appear. There is no constraint. But the only constraint is only two zeros. Here the thing is, on Q2, if 0 appear, what happened? Already two zeros are completed. Again, if 0 appear means it is not allowed. That is the reason whenever a 0 appear at the last state, I am moving to a dead state. Assume here QF is a dead state. Anyway, for this the transitions are 0, 1. Now you understand? This is the DFA that accepts exactly two zeros. Now move to the question. At least two zeros. What is the meaning? Minimum two zeros are required. Suppose here I am changing the language. See, two zeros. 1, 0, 0. This is accepted. 1, 0, 1, 0, 0. This is accepted. Suppose 1, 0, 1, 0, 1, 0. This is accepted. Minimum two zeros at least. For example, 1, 0. These type of strings are rejected. These type of strings are rejected. Now, same 0, 0. Here, if you want, you can write any number of zeros. What I am doing, depending on the requirement, I return the self loop as 0. I return the self loop as 0. Now, how many number of zeros you want, you can write that many number. You can take any string. For example, 1, 0, 0, 1, 0, 0, 1, 0. Observe, on 1, Q0, 0 moves to Q1, 0 moves to Q2, and 1. Q2, 0, Q2, 1, Q2, 0, Q2. Finally, I am at state Q2. The string is accepted. Clear? Minimum 2 means we will compulsory return 0 as the self loop. Depending on the requirement, you can take that many number of times. Clear the points? Now, the most important, at most. What is the meaning of at most? Maximum two zeros are allowed. So, this is the case. Two zeros and 1, 0. This is accepted. 1, 0 is accepted. Suppose 1 is accepted. That is without 0 is also accepted. At most means either 0 number of zeros or 1 number of zeros or 2 number of zeros. Single one is also accepted. For example, 1, 0, 1. This is accepted. 1, 0, 0, 1. This is accepted. You got it? Suppose 1, 0, 0, 0. Such a type of, here it consists of three zeros. Such type of strings are not accepted. Now, how to draw this one? Very simple. Whatever we written for the at least case, simply change the final and non-final states. Suppose I am erasing this one. Again, rewrite the same logic. Initially, I am at state Q0. Initially, I am at state Q0. Now, this is marked as a final state with 1. Right or wrong? That is without any 0, this one accepted. For example, 4 ones, this must and should be accepted. That is 0 number of zeros is accepted. Now 0, I am moving to Q1. So this is also final state. Why? With 1 0 is also accepted. Here this is the case for accepting 0 number of zeros, and on Q1 this is the case for accepting one number of 0, and 0 moves to state Q2. This is also accepted. That is 2 zeros are also accepted. Now self loop 1, self loop 1. Clear? The maximum 2 zeros. And again, what happened if 0 appears on state Q2? The same logic. On 0, we are moving to some dead state. Now observe, with the 2 zeros only, I am in the final state. Maximum 2 zeros. So the first two exactly 2 zeros and at most 2 zeros, almost same. What is the difference? In the first case, only 2 zeros are allowed, then only that is accepted. In the second case, minimum 2 zeros are allowed, maximum any number of zeros. That is the reason I written the self loop. But in the third case, maximum 2 zeros are allowed, means only 2 zeros are maximum, is 0 number of zeros are accepted, 1 number of 0 is accepted, 2 number of zeros are also accepted. This is the finite automata. Thank you.